Hey y'all, so today we're going to do part 2 of the binary tree. So I know I promised that we were going to do the search and delete functionalities in this video, but I actually recorded a video for those both and it ended up going over 30 minutes long. The reason because the delete method, it's a little hairy. It introduces a number of Rust constructs that need explaining, and it just blew out the time. And you guys know I want to explain this stuff the right way so that you understand it. I don't want to take shortcuts when it comes to helping you guys understand this stuff. So we're just going to have to do a third video. It is what it is. Hopefully we don't have to do a fourth one just to cover the theory in the third one. But yeah, so we're going to we're just going to implement search today and go through it. Okay. Also, I noticed that I had this named right node, so I changed it to right child to be consistent with the left child. Okay. All right. So let's do search. Okay. So we're going to do two methods here. And also notice we're going to be using references this time, since we're not really, we're not manipulating anything. We don't need to drop anything or anything, so or consume anything. So we're just passing references. All right. And this is going to be a reference to a box, a tree node wrapped in a box. This is just going to be another reference to a value, and then this is also going to return bool. Alright, okay. Now, so we are going to match on self.root false, and then if we do find something, we are going to pass it that something and the value. Okay, so what are we doing here? Alright, so we're matching on the root. So if it gets here, the tree's empty. There's no root, so that means there's nothing in the tree. If there is a root value, then well, we need to make sure that it's the value that we're checking, that we want to assert, that we're looking for. And if it's not the value, if the root node is not the value that we're looking for, then we need to look for it. Okay. So down here in search node, what we can do is we can do if visited. Right? Value equals node.value. True, right? The node that we're looking for is indeed the root node, and yeah, we just return true. There it is. Okay. Now, if value is less than node.value, nothing else. Okay, so if the value that we're looking for is less than the current node, what do? We go down the left subtree of the node, right? So we're going to match on node.left. Okay? Now, if we get none back, it's just going to be false. If we do get something back, well, we have to make sure that that something is the node that we're looking for. So we need to go back through search node. Okay, so what is this doing? All right, so let's go through it. Okay, so let's say that we have a root node. Okay, so we go through here, and this value is the value that we're searching for. So we're initially comparing it to the root node. So if we come down here and we get true, then okay, the root node is the value that we're looking for. Okay, if the value is less than the root or whatever value or whatever node we're looking for, then it goes down the left subtree. If there's nothing there, the value does not exist, right? Because think about it. If the value that you're looking for is less than the current value, well, it has to be on the left because only larger values are on the right. So therefore, it's not there, right? This lesser value does not exist. Now, if we do find something over there, we have to make sure that it's the value, right? So so it goes back through. If it is the value, then we get true. If not, we do another comparison, right? And now, what do we do? What else do we do? Like now, if it does, so if the value is greater, what do we do? Well, you should know, we just go down the right side. Right? That's it. We just do the same thing on the right side. Okay? So let's take a look and see what we got. Okay? So over in main, we see our original binary tree where we added our nodes, which gave us 10, 5, or 5, 3, and 7 on the left of 10 and 15 on the right of 10. Now we're going to do a search. We're going to search for 15, 7, and 9. So let's see what we get back. Okay, so let's double check our tree. So in our tree, we have a root node which has 10. It has that root node has a left node that has a value of 5. Okay, that value of 5 has a left node of 3. Okay, well that's it. The tree stops there. And then 5 has a right value of 7, and it stops there. There's no children there. Okay, then 10 has a right child of 15, and there's no children. So, right, 15, 7, we have those, but there is no 9. Right, so we're successful. We found the values that we were looking for. Okay, let's go over the notes. Now, so references, right? We're using references here because we're using them instead of moving or cloning values, right? So this lets us do comparisons without taking ownership of the value. Okay, so here's our code. All right, so this is pretty much what I've already told you guys, right? So we start a search. We start our search using search, okay, which begins at the root of the tree. If the root is none, the tree's empty. There's nothing there, right? Now, if there is a root node, we go into search node, okay? And if there is a root node, we need to compare it to the value we passed to make sure that it's the value we're looking for. If it is, we return true. If it's not, is it less than the current value? Then we go down the left. If it's greater than the current value, we go down the right. Okay? If we get none back from left, it doesn't exist because we're looking for a lesser value that is not in the left subtree. Therefore, it doesn't exist. It has to be in that left tree. The same thing for the right. The greater value has to be in the right. If it's not there, it doesn't exist. If we do find a value, we recurse to make sure that it's true. If it's true, we found it. If not, we have to do the same thing that we did before on either the left or right side, depending if the value that we're searching for is lesser or greater. Okay? So down here, okay, let's say that we want to delete this 7 down here, right? So our initial call is we start at 10, the root. And since 7 is less than 10, we know that we need to move to the left. So we see that 5 is over there. Well, that's not the value that we're looking for. But we send it back through, right? So we send it back through, and it's like, nah, this isn't the value we're looking for. The value that we're looking for is greater than this value. So then we go to the right. Then we find 7, and we send it back through. And then sure enough, value equals node dot value, right? 7. And that's it. That's how it works. If you understand the insert node logic, this is basically the same thing. Okay? All right, guys. So that's it for this one. Like I said, we're going to get to part 3, and hopefully that'll be the last one where we implement the delete functionality. Let me know if you have any questions about search. Ask respectable questions to get respectable answers. Help each other out in the comments. And yeah, I'll see you in part 3.